I am recording the Zoom though, because there's still a couple people who aren't here. So hopefully if they didn't see my message or something, they can get to that later. Now, for the sake of time, hopefully you got these written down, but I do want to get to them quickly just so that I can walk through them. All right, there's a couple different types of equations here that we prepare for, but what I want you to see that as we get ready for a test, I can start making up equations at this point, and we should be able to, one, identify what we're working with and be able to start highlighting the strategies to solving it because of what we're working with. Okay, everyone follow that? With that said, though, as you see here, I have 5 different equations, all right, variety of types. There's some things that we don't have on here that we should definitely be practicing, was like rationals. Make sure you see that. That was one of the problems. Like if we go back to what would have been the day before, this is what the problem set might have looked like, okay? Now, as you can see here, I had some rationals as well as some of the other ones we're about to look at, but just kind of give you an idea of the variety I would have done if we had that extra day. Now, my plan is to make sure we're clear is, as I mentioned, Tuesdays, I think the test on Thursday is going to be our best approach, okay? As of right now, I'm not going to try to change too much as far as the calendar is concerned. So I'm going to bump the test back to Tuesday. We'll have another lecture day Monday and then review, okay? Monday, our focus is going to be on some linear inequalities. Okay. We'll see if I change my mind over the weekend, but that's kind of where I'm looking at. And that way we will have Tuesday and Wednesday to have a review before we take the test so that any questions or concerns can be taken care of. Okay.
So do you want to push the test back to Thursday?
The test is going to be on Thursday. With that said, though, the final deadline for the homework assignments that were due, like I'm leaving the due date for today, but they have to be done by Wednesday. I bumped back that date of last completion that we talked about for no penalty, right? You can complete them by next Wednesday now. So I bumped that back 2 days as well. Is that clear to everybody? So the due dates will still say the 13th, but know that you can still work on them up until Wednesday by 11. If you have issues, what should you do? Email me, right? Get in touch with me through Canvas. I don't think someone asked me about Ed Puzzle, but apparently it worked because I didn't hear anything back. That would be one I'm not really sure about. But the My Open Math, from what it sounds like, we could still access those, no issue, as well as the Pearson side of things. Okay. You can get back into them. All right. So that's good to know. So, okay. I was about to say, I saw you email me yesterday and I think I got bombarded. There were several emails that did not go through yesterday.
Yes.
So I'll try to give us a few minutes at the end just to show it to me. I'll probably just do that on Monday though, to be honest. Let's just do the in-class quiz. If you have your work, bring it with you Monday. We'll close it out Monday. I'll make sure to take time Monday to do that. Is that good with everyone? Because the whole point of it was to get it done this week, right? And then losing 2 days, let's just bump that one back to Monday. That was just for extra practice. And he was, what grade did I say I was going to give you once I saw your work? 100%. That was my main thing. I want to see your honest attempt at it. Okay. That's the key. Now, with these problems here, though, what is this first problem? What type of problem are we looking at? So there's multiple steps here involved. Specifically, what are you going to have to do first? Distribute. So we're going to have some simplifying, right? What are we going to get when we distribute, though? All right. So the key is here is to make sure we see that we're going to have an x squared at some point, right? So as you look at that and say, hey, I'm going to have to simplify this, right? Make sure you know to yourself that there's going to be an x squared here. With that said, this is something that we can then go and say, hey, this is a quadratic equation. Being a quadratic equation, right, after I simplify, what do we need to get? So if I go through here and I simplify the equation, what do we do now? All right, what are we trying to do when we get everything on one side? We need equal to 0, right? So one of the things that we talked about quadratics or even polynomials in general, we need to get to the point of equal to 0. One side has to be 0. Does it matter what side? No, right? As long as one side is zero. Okay, so we need to go in here and get these terms out of the way. I'm keeping that 3x squared positive. That, remember, that's my focus. But that would give us what? 3x squared minus 13x plus 25 equal to 0. Are we in agreement here? If anyone got that already? It should. My bad. Why is my phone going crazy right now? All right, so sorry about that. Now this changes a little bit, right? That look better? All right. By the way, I see a couple people came into Zoom just now. Please, if for everyone on Zoom, can you put your first and last name in the chat? That way it's in the recording and I get everyone for the role and I don't miss anybody. So just put your first and last name in chat and I'll take care of that later. I'll get you in a second. That I'm gonna try to. I can't, it's not gonna be a perfect video though, y'all, when I post it, just so you know. It's not my ideal situation of doing that, but it'll work for now. Okay. And it's actually working better than I tried to when I did last week. So it's good. Right. But now we're in that general quadratic equation situation. What can we do to solve this now? We could factor it. Is everything going to factor though? No, right? So when it doesn't factor, what could we use? Quadratic formula, right? And what was that other fun one that we can use that I walked through a couple times now? Completing the square, right? So understand once we get here, those are the things that we're thinking about. Hey, I could factor, complete the square quadratic formula, right? Now, just remember the completing square and quadratic formula are kind of linked together because that's where the quadratic formula comes from, right? Here, A is 3, right? So I definitely hope it factors because I don't want to have to do completing the square with this, right? So if it didn't factor, I would go to the quadratic formula here. Okay, as we saw the other day, you could still complete the square, just the fractions get a little bit more involved as you go through. Okay, with that said, though, A times C is what, 12? And our B value is 8, which actually works out nicely, right? Because what two numbers can we use? Mm-hmm. We all comfortable with that? Now, with that said, though, I like the factoring by grouping approach. This is just something that from my teaching experiences that I started doing. I always did trial by error. But once I started teaching, I like this approach because it gives you a chance to write something out, as I mentioned before, and kind of use a process rather than just have to memorize. But what we hopefully see here is that these first two share something in common because I put the 6 first, didn't have to. The second two share something in common. More importantly, the parentheses end up being the same group, which confirms that, yeah, we should have been able to factor. Okay. With that said, though, when you choose to factor, right, which remember, as far as polynomials, we have to know how to factor because that might be our only option on some problems. What do we do with our factors? Once we get it here, what do we do with our factors? Set them equal to 0, right? So x plus 2 equals a 0. Subtract 2 from both sides. 3x plus 2 equals 0. We subtract the 2 from both sides. and then divide by 3. Any questions or concerns? Now, not every problem is going to look exactly like this one, but this could have been one of those rational problems that you just simplified by eliminating fractions, and this is what you're left over with. Okay, so no, I may not give this to you a problem like, hey, solve this, and this is where we're starting, but we have to be prepared to, even when we work through problems, start to identify what we're working with. Is there any questions, concerns I can help with this one? All right, so let's go to the next two then. What type of equation do we have here for that second one, letter B? Huh? Not a square root, a cube root, right? Now, a general way to write that would be like, hey, this is a radical equation. But the fact that that's a 3 is the important part. That's going to be the n we talk about. So if you hear me say like the nth root, right? When we start talking about radicals, we're going to talk about square roots, cube roots, or more, right? So in this case, we would say like, hey, n equals 3 because it's the cube root, okay? Now, as far as the cube root is concerned, make sure you go back and have some ways to remind yourself, like, hey, the cube root of 8 is equal to 2, right? The reason being 2 times 2 is 4, times 2 again gives us 8, right? So that's a good way to remind yourself, hey, a number times itself 3 times is what we're looking for. Now, with that said, though, what do we do to solve a radical equation? Whenever you have a radical, we can use what? Huh? How would you write it? Huh? Put parentheses on both sides? Like this? And to the third power, right? We raise it to the third power. We use an exponent, right? When we start talking about exponents, one thing we can do to undo exponents or undo radicals is use one with the other. Now, this is the difference, though, because we know what the root is, right? The root is 3, so we use an exponent of 3. We're going to get to a point where our exponent will be our variable, and that's a whole different conversation, but that's something we'll get to. But when you know what the root is, or you know what the exponent is, hey, they go well together, okay? So that on the left side here, we'll just have 2 minus 3y equal to what? We're all in agreement, 27? The radical's gone now, though, so what are we working with? It's a linear equation, though, right? So key is linear now, right? Let's subtract the 2 from both sides. And then divide by the -3. Be careful with your signs here, though, because it might have been tempting to drop that negative when you're solving this. So we have to be careful to see that that -3 should not change until I divide by -3. Are there any concerns with the value we just got that shows us the solution?
So what do you like? I think that's like that question with that 3, if I would, that's above the square.
It could be, yeah, I could do the 5th root, I could do a 4th root, right? Now, the key to remember, though, is right now, are we okay with negative as an answer? Yeah, right. Remember, cube roots were fine, but like with the other numbers, just remember to go back, like with 4th roots, 6th roots, always go back to the square root. Hey, I just got to watch for signs when they're even. Okay. Now, for the most part, as far as the test is concerned, I usually do square roots and cube roots because if we can do those, we can handle whatever number it is. Okay. Any other questions or concerns there? All right. So what's going on with letter C then? The third one. This is absolute value, right? So we definitely want to be careful that when we're dealing with the absolute value, what should we do first? Why are you moving the 11 right off the bat? We got to get the absolute value by itself, right? So make sure you see here, like this was the highlighting portion that we're working with. So we got to get that piece by itself. To do that, we do need to subtract 11 from both sides. So we have the absolute value of 7W plus 9 equal to -9. All right, what's next? Can we take stuff out of the absolute value? No, there are certain situations we can make arguments, like if it's multiplication, but we cannot add or subtract anything that's inside the absolute value symbol. So what do we do with it here? What is an absolute value? Distance from 0, right? So at that point, how many numbers are -9 from 0? None. The problem is we just said it's a distance formula, right? By it being a distance formula, what's the issue we have right now? It's equal in a negative number. Distances will always be positive numbers. That's the thing that you want to make sure to have a note to yourself. Distances are must be positive. Yeah, so here we would conclude no solutions. Now, remember though, if you look at that, if it was a positive 9, then we would say, hey, you can go 9 to the right or 9 to the left. Well, if you go 9 to the right, that's positive 9. If you go 9 to the left, well, guess what? There could be a -9 as a solution, but we cannot have it as our distance, okay? Now, there are different math classes or different science classes where you might use a word like displacement, where the direction of movement is important, right? But when it's a simple distance, we don't want the direction. We just want the distance. That's what's special about the absolute value. Okay. Are we good with that? Now, is that going to happen all the time? All right, go back to what we did the other day, if I could find it again real quick. So as we saw here, I did a very similar problem, but this one was the absolute value W plus 2, and we had to add the 4 to both sides. But this time it had a positive 7. So this is what we got done, I think it was Tuesday before we got sent home, right? So the key here is that's a positive 7. So at that point, we can go 7 to the right or 7 to the left. So that's where those two values came from. So understand at that point, you need to separate it into two solutions. What's the only number that would give us one solution? What distance is the same no matter which direction we go? It'd be 0, right? So understand if you have a distance of 0 plus or minus doesn't make a difference, right? Whether it's positive or negative, it's still 0. Okay, so be careful because that could happen. Any questions or concerns though with absolute values before we go on? All right, so the next one here is another fun one. Huh? Did I change it? Oops. Wait, what happened? Uh-huh. Yep. I see what I did. I'm sorry. I changed it here and not there. We did that one on Tuesday. Or a similar one, I should say. Huh? No, I forgot I had I didn't copy it over though. All right, so everyone's got this problem, right? So with that said though, what's going on here that makes this one unique? What's the power? It's 4, right? So the key that you need to say there is polynomial. Oops. Well, that's why we just say polynomial, and the way that we would say it is degree 4. The degree of the polynomial is 4. Okay. What does the 4 matter to us though? What is that for? Because that 4, there's a reason we highlight that, right? The highest exponent we have right now is 4. So for us right now, what are we going to take from that? What are we trying to find? We're trying to find numbers that make the statement true, right? What's the name we gave that? A number that makes the statement true is considered a we solve to find solutions, right? How many solutions does this equation have? That's the key there, right? Hey, I'm trying to find 4 solutions right now. That doesn't mean I'm necessarily going to get 4 unique ones, but I'm still need to find 4 solutions here. Okay. I kind of briefly talked about it before, and I'll try to think of one I can give to you Monday. But we have something called multiplicity. And what that means is 2 solutions happen to be the same number. That can happen. Okay. But in order to solve this, what do I do first? Right. So we have to get everything on one side so that we have it equal to 0, right? So in adding this 20, oh, sorry, subtracting the 24z from both sides, we'll have what? 3z to the 4th minus 24z equal to 0. And what can we do now? You can divide by 3. That's fine. Nothing's wrong with that, as long as you don't divide by z, right? What's another thing we can do now? We can factor it out, right? So whether you divide by 3 or factor out the 3, that's definitely important. But the reason factoring is important, not the 3, but the z, right? Now, I have no issue with you dividing by the 3, though. Keep that in mind. Like I said, it makes the numbers a little bit nicer. Just to stay consistent, though, with what I've done on other problems. And we're going to write it like this. Now, this is where it gets a little bit different. All right, so here we have to make sure that we see what is the exponent that's left over in the parentheses now. It's a 3, right? With that in there at 3, we have one solution already isolated, right? But we got to deal with this. So how do I factor this thing when it's only 2 terms and z cubed? All right, this is a formula that we have to have down. We have to have this formula memorized, okay? Now, you could do a cube root, but the cube root's only going to give you one answer. All right, that's why we need to have the factors so that we get the other 2 answers involved. But remember here, we take the cube root of both of them, and then we got to fill it out, right? I'm putting a squared because we still need to have a cubed, right? Over here, I'm going to put b squared because we still have to have b cubed. The middle term is just multiplying them together, but what am I missing right now? What did I not put in my statement? My operations, right? So what word helped us here if we forget? Right, so, right, same, opposite, always positive. Okay. Now I use this kind of in a general way of saying a cubed and b cubed. Just remember when you see 8, though, we could be like, hey, that's 2 cubed, right? So when we go down here, we can say we can actually factor this. My first factor will be z minus 2. Make it 1z and 1, 2. But then just make sure as you build this other one, you have to get back to what you had, right? So if I have 1z, I put 2 more to get back to z cubed. If you have 2, well, you're going to need a 4 to get back to 8. Right? But at that point, just remember, if you have something that's squared, we're looking for 3-term quadratic, right? So that might help you remember to put the 2 and the z together. That's the one where the formula comes in and helps us understand that. If you remember, though, on the quiz and earlier this week, we multiplied this out to make sure to see that, yeah, that definitely does simplify to 2 terms. But then both of these will be positive in this case. And the whole thing still equals 0. Now, with that said, though, we can't factor any further. When you use this formula, know that you cannot factor this last one. If you recall what I said, whenever you use this formula right here, expect this to not factor, that you're going to have to use the quadratic formula completing the square. All right, and more than likely, guess what? We're going to have some solutions with the letter I in it. Okay, so expect complex solutions. Is there any questions or concerns getting here though? So we're all good with getting here. Now, for the sake of time, because I want to make sure I have time to go through those other ones, this piece here, make sure, as I said, the quadratic formula is how you technically would solve it. All right. But A is already 1 on here, right? There's nothing in front of the Z squares. That means A is 1. I'm going to go ahead and complete the square. I like completing the square with this one, though, because when we complete the square with this one, it's a little bit faster than quadratic formula. But the key is like, hey, I could not factor this, so that's why we're going to complete the square. The quadratic formula is perfectly fine here, so please keep that in mind. To complete the square, though, that's where we go in here and say, hey, what's half of B squared? Well, B is 2, right? Half of 2 is 1. With that said, know that half of B is what your factors are going to have. That's why we need half B. We just broke the 2 in half, so that means both factors better have 1, because 1 plus 1 is 2. But you can't factor unless you have 3 terms. So that's why we do the whole squared part and say, hey, let's add that to both sides. That's why that's important. Okay, so keep that in mind. Once you get here, though, this is where you could see why you can't factor. I have this thing that's being squared equal to -3. There's our issue. That's, as I mentioned, watch out for complex solutions. Okay, because here we got to go do the square root of both sides. So that'll give me Z plus 1 equal to plus or minus the square root of -3, or is equal to -1 plus or minus the square root of 3i. So if you use the quadratic formula, and that's what you prefer, make sure you have this written down for an example of completing the square, but also make sure you could do the quadratic formula and get to that same 2 solutions. With that said, it is 2 solutions. We had 1 solution here, a second solution here, and then the third and fourth solutions are there. Okay. Now, do know on the test, you will need to be able to do the quadratic formula or complete the square. So make sure we're practicing that and that we're comfortable with it. And be prepared to write on this test. That's another thing I would tell you. Know that, hey, as I deal with this, I'm working through steps for a purpose, right? Now, not every problem is going to look like this, but make sure you're going through it here and like highlighting a little note to yourself. Why did I get this? Why was this important? Okay. Hey, that's equal to 0. Now I can go factor. This is you factoring this out, a greatest common factor, right? The place we should always start is check for greatest common factors, right? This next step is a special factorization. This doesn't happen all the time, but this is a special one that I should keep an eye on, okay? That's what I wrote up here, and you can also do it with the sum. Whenever you have cubes, it can be the sum or difference. That's why I gave you the word SOAP, though. Just remember, same, opposite, always positive. Lastly, this is us setting our factors equal to 0, okay? What made this one special, though, is whenever you get this point, you're going to have to solve this without factor. So as I mentioned, I chose completing the square, but the quadratic formula works fine here. If you prefer the quadratic formula, make sure you do that on your own time. And hey, that we're in agreement here. Okay. Anything I can clear for somebody? All right, then. So the next one that we had was this fun one. Why do I say this is a fun one? Huh? It's an absolute and a quadratic, right? Where is that quadratic at though? Inside the absolute value, right? Now, understand at this point, we can mix all kinds of stuff up, right? I'm not necessarily going to do that on the test, but like if you said you only wanted 5 problems on the test, this is the type of problems I would probably put on the test. I don't think anybody's asked, but when you ask how many problems on a test, be careful what you ask for. The fewer problems, the more they look like what we see here. I could test both the absolute value and the quadratic at the same time now, right? With that said, which one do we deal with first? Absolute value, right? The absolute value is on the furthest outside. Since the quadratic's on the inside of the absolute value, I got to deal with that first. So can the absolute value equal 8? All right, so we're all good there that we can have 8 over here. So we're good here. With that said, how many equations should I write down now? 2, right? Because we could go to the right of 0 and to the left of 0, right? So that's our key there is we could have 2 solutions. So this thing here can equal positive 8 or negative 8. The fun part is that I make these factorable or not. That's going to be the fun one. Right? Wouldn't that be fun to make one where it can factor and one you have to do the quadratic form and I test everything with one problem? But are we okay with where the 8 and negative 8 are coming from? What do I no longer have though once I make this? Right? But what we're saying here is we have the definition of the absolute value before us, right? So when I see this by definition, the absolute value of 8 equals 8, the absolute value of negative 8 equals 8. We've applied that definition. Okay, so remember, that's one thing we've got to be careful of as we saw with that negative one earlier. Okay, we had a negative value, so that was where we're being careful by definition. Okay, with that said, though, what am I doing here? All right, so we had to get it equal to 0, so I had to move the 8 and the negative 8 into 2 different equations. Now, you don't have to solve both of them at the same time, but both equations, we have to deal with that 8. So just make sure to see here, this one we subtract it from both sides, where this one we add it to both sides to get 0. All right, now we can jump into our factoring though, to see if it works. So here we get -7 and +6. So do factors of 7 subtract the 6? They do, right? So as long as I use -1 times 7 and -1 plus 7, that's nice. All right, now for the sake of time, I've already done factoring by grouping today. Okay, for the sake of time, know that means I could write this as x minus 1 times x plus 7 equal to 0. Which we have 2 factors equal to 0 now. So I can set each of these things equal to 0 themselves, because one of them has to be 0. Add a 1, subtract a 7, and hey, I got 2 solutions already. What am I going to get if I plug in 1 or -7 though? Non-zero. It is 0. Yeah, okay, let's be careful. Sorry. It's 0 for this statement. Yes. Yes. But if I plug it in here, I'm going to get 8, right? Because the absolute value of 8 is 8. It is 0 for that step. Yes, that step here would be 0. Okay. But if I plug it into here, which is where I got it from, right? I would have the absolute value of 8 equal to 8, as mentioned. Okay. The big difference here is when I get these solutions from this equation, that's going to be where the -8 comes in. Okay. The absolute value of -8, well, hey, that's still 8. Okay. But what do we like about these factors? What two numbers can we use here? So we can't factor it. It's definitely one of those ones to be careful. That's another special factorization, right? This is what we call a perfect square trinomial. Okay. So we can come down here, and again, I'm skipping the steps of grouping because we did it already today. But both those factors are exactly the same. If you wanted to, you could write it as x plus 3 squared and use the square root property. But just remember, there's no such thing as positive, negative, 0. Okay. But if you use the factoring approach and you set them both equal to 0, I think it's better for just the sake of highlighting the fact that both of them give me what? -3. If you write that as x plus 3 squared and use the square root property, awesome. No big deal there. Just don't put plus or minus 0. Okay. But here, what I want us to make sure to see is I just did all that work and I found the only other number that works is -3. I like the factored approach though, because hey, we had 1, 2, 3, 4 factors, but how many solutions? We had 1, 2, 3 solutions. So we should only type in 3 things. Is that clear to everyone? Or write down 3 things. Now, this is what we call multiplicity, right? When we start graphing polynomials, we could talk about how that impacts the graph, because that's where we see its impact is like on a graph or something. Just know that this can happen, and it's good to recognize that, hey, there was multiplicity here. But for us right now, it's just making sure to see that, hey, I still got my 4 solutions. It just happens 2 of them are the same number. Does everyone follow that? Now, with that said, it seemed like this was going to be a lot more, right? But hopefully what you see here, as long as you take your time and unpack things one step at a time, follow those strategies, recognize what you're working with, right? Hey, we need to recognize it was absolute value and quadratic here. Go through those steps of what to deal with, right? Since the absolute value was on the outside, I had to deal with that first so I can get it out of the way, right? Which is why we solved 2 equations and not 1. Is by definition, the absolute value, I can go to the right or left of 0. They could, but we don't need to go that far, because what you're going to find is that goes back to, if I remember, I don't remember if I kept it though. Let's see. I think I erased it, but when I was talking about this here, I said you could have wrote this like W plus 2 equals 7 and negative W plus 2 equals 7, right? That's another way to apply the definition. The key is I just chose to make the other side negative rather than the number itself. You're going to see like there are situations where you're going to have to do that. So it gets a little, it doesn't necessarily make it harder to solve, but it's just the way the definition gets applied. It's a little bit messier. Hopefully what you saw with the one I just did, yeah, it wasn't as nice as something that's straightforward like this, which is what will probably be on the test, by the way. Y'all keep that in mind. Look at this one and the one we did today as far as a kind of what to prepare for our test. But that quadratic one, that one worked out kind of cleanly, right? Just break it to the 2 and hey, look at that, I got to solve 2 quadratics now. Okay, but it can happen. They do get more complex. But our folks, I just wanted to make sure to see that, hey, one step at a time. All right. Rationals are the ones that we definitely have to be ready for, right? As far as those fractions are concerned. So I believe we did one here, didn't we? I don't think we got to this one though in class, did we? Yeah, we did, because we talked about extraneous. This, I don't remember if we did this one in class. This would be a good one to take a picture of though, or take a screenshot of, because I don't have time. We only have 5 minutes left to do this today. So I definitely don't have time to do this. But the key is to make sure you highlight that this is the original equation. And we went through our steps. So here, this is us eliminating the fractions. That's the point of that step. So that once we got here, there was no fractions left. But as I talked about the first one we worked on today, make sure you see that when you stop simplifying, oh, now it's quadratic, right? I start eliminating fractions. I start simplifying. I get a quadratic. That's why we got it equal to 0. Okay. And then we go and solve. Now just be careful here again, as we talk about that absolute value having no solutions, make sure, remember, don't divide by 0. That's why this one didn't work. Okay. Any questions or concerns as we finish up today? What you got? Quadratics are used almost every day in everything you look around. You like basketball, right? You can't get away from quadratic. When we start talking about graphs right now, when you start breaking down players and their shooting habits, quadratic right there. You don't want anything negative, right? So that's where the absolute value might be helpful in the analytics of software. You know, I know like I, as a sports athlete, we didn't have a lot of software to help us. But nowadays, you could pull a video and just start recording people's shooting habits and say, hey, look, you keep changing your habit. When you don't have your release point right where it needs to be, it throws off the what we're going to call a parabola when we look at it from the function perspective. That would be a great example of like a quadratic here. The absolute value would be the fact that we don't want any negative values because the ball should be going up, not down. Right. So when it boils down to it though, like that would be one example, engineering. As I mentioned, we had those complex stuff. So when you start talking about circuitry, that's where that comes into, right? Not everyone is going to do the math, but it's kind of like how many of you heard about them doing, was it somewhere in California, Livermore Labs, if I remember correctly, they successfully did a test where there's a special reaction. I don't remember the name of it right now, but it was like, hey, we were able to do this and we actually gained energy, not lost energy. Well, the scientists are the ones sitting there having fun, just playing with stuff to see if they can get it to work. Well, guess what? Next got to come in the engineers, someone who sits down and does the math to make it practical to have everywhere else, right? So that's another example I would use is someone's got to have the ability to sit down. For y'all in here, though, like I said, most of y'all are not going into engineering. So it's about problem solving skills. That's why I focus on let's make sure we unpack it, take it a step at a time, recognize what we're working with, and be prepared for stuff to change as you work through it, right? As you deal with one problem, reassess and make sure we take that as we go with us. All right. Anything else? All right. Well, stay safe this weekend and I'll see y'all on Monday. All right. I'm shutting off the Zoom. So y'all have a good week.